Hi guys, welcome to the movie about standard deviation. Just give you a second here to get sort of a sound check. Check. How does it sound? Make sure your headphones sound good. And let's get started. So, standard deviation is a tool used to measure how spread out a data set is, how much it varies. It's a measure of variation. So, we're going to be studying a normal distribution, the normal bell curve shaped, just to get the basics. So standard deviation can apply to any shape of data set, whether it's skewed right or skewed left or normal/symmetric. So we're going to be just looking at a normal distribution to get the basic idea. So a standard deviation measures in a normal curve, we know that the mean, the average, is right in the middle if it's a normal distribution. And the standard deviation tells us how much data, how far the data is spread away from that mean. So one standard deviation away from the mean, either direction, going -1 or +1, one standard deviation away from the mean will always include 68% of the data. So that standard deviation could be any number. It could be 10, it could be 100, it could be 2. But one of those standard deviations away from the mean includes 68% of the data always. So that number just tells us that the 10 or the 100 or the 2 tells us how spread out the data is and how far away from the mean you have to go to get that 68%. But it will always be within one standard deviation. If we go, here's the mean in the middle, if we go 2 standard deviations away in either direction, then we'll be including 95% of the data. And if we go 3 standard deviations away from that mean in the middle, then we will have 99.7 or almost all of the data. We'll have if we go 3 standard deviations in either direction. So the mean being in the middle is because this is a normal distribution. The median is always the dead center, the middle of it. But if it's normal, the mean and the median will be very similar. So the standard deviation is going to measure how far your numbers in your data set get away from that mean. So given the mean and standard deviation, we're going to find all of the values between minus and +3 standard deviations from the mean. So they're going to give us the mean and the standard deviation. So on this problem, they're telling us the mean is 48. So we know the number right here in the middle at 0 standard deviations is 48. These numbers here, 0, 1, 2, 3, are measuring the number of standard deviations that are occurring. But the mean is 48. The standard deviation is going to be 2.5. So if we're going to do the interval between 68% of the data, we're talking about plus and minus 1 standard deviation. So we're talking about from here to here. Okay, so we know that the standard deviation is 2.5, so we're going to minus 2.5 to go this way and plus 2.5 to go this way. We're going to add or subtract 1 standard deviation from the mean, which is 48. So if we put in your calculator, and you can pause this if you need to get your calculator ready, put in your calculator 48 for the mean, and then minus 2.5 from it. And that's going to give us 45.5 right here. 1 standard deviation that direction. If we put 48 in the calculator and we add 2.5 to it, we're going to get 50.5. 1 standard deviation away in the positive direction. So the interval between 68% of the data is 45.5 to 50.5. That's the interval. That includes one standard deviation, which is 68% of the data. If we want the interval between 95% of the data, remember that that is 2 standard deviations. So now we're going to do minus another 2.5, add another 2.5 to go to the second standard deviation. So we can use this number here, the 45.5, and we can minus another standard deviation from it. And the standard deviation on this problem, remember, is 2.5. So 45.5, take away another 2.5, will give us 43 even. All the way to, so this is 43. And if we add another standard deviation going this way, so we take 50.5 and add another 2.5 to it, make sure you're doing this yourself on your calculator, you'll get 53. So this data, in 95% of the data, 2 standard deviations from the mean, go from 43 to 53. And then the interval for 99.7% of the data goes all the way to that third standard deviation away from the mean. So the mean's 48, standard deviation is 2.5. So if we minus another 2.5 on this side, 43 minus 2.5, again, please do it yourself so you're sure, you're going to get 40.5. So it's going to go all the way from 40.5 all the way to, if we add another 2.5 here, we'll get up to 55.5. So if the mean was 48 and the standard deviation was 2.5, then 99.7% of the data is between the numbers 40.5 and 55.5. You start to get the idea? What you should do is pause the video, do it yourself, and see if you can figure out this second one. So it's the same sort of problem. We're going to go 3 standard deviations, one by one. We're going to go 1 standard deviation to get 68% of the data, a second standard deviation on both sides to get 95% of the data, and then 3 standard deviations on either side of the mean to get 99.7%. But this time, the mean is 76, so that's our number in the middle. This is a normal distribution. And the standard deviation is 8. So it might be a little easier because we're going to be working with 8 every time. So pause this, do it yourself, and then come back and see if you got it right. To get 68% of the data, you're going to do 1 standard deviation. So you'll minus 8 plus 8. So that's going to give you 84 over here, and it's going to give you 68 over here. So that will go from 68 to 84. Then for the next standard deviation, which would get us 95% of the data, we'll minus 8, getting us to 60. We'll add 8, getting us to 92. So that interval would be all the way from 60 to 92. And then this one, for the third standard deviation, to get us to 99.7%, we'll minus another 8, taking us down to 52, and we'll add another 8, taking us up to 100. So the interval for 99.7% of the data in this set would go all the way from 52 to 100. You can see that this data is much more spread out than the one in example 1. Since the standard deviation is bigger, it's 8 versus 2.5, it means this data is more spread out, has a bigger range. All right, do one more here, and I'll cover it as an example, but by all means pause, try to get ahead of me, and then see if we matched up. So now the mean is 1.24, tiny little number. And the standard deviation is 0.004, very, very tiny. This data is all very, very, very close together. So if we minus 0.004, this is going to cause you to have to be careful with your calculator to not do any typos and get enough zeros in there. So 1.24 minus 0.004 is going to give us 1.236 on the low end of that first interval, and 1.24 plus 0.004 is going to give us 1.244. 1.244. So this interval would be from 1.2, sorry for the mess there, 1.236 all the way to 1.244. And then we'll do the same. 004. Whoops, this is kind of messing up on me. So 1.236 minus another 0.004 is going to give us 1.232. 1.232 all the way to, we add another 0.04 to this, so we'll get 1.248. 1.248. And then when we do the third one, take away another 0.004. That's going to give us, and you're doing it in your own calculator, 1.228. 1.228 all the way to get 99.7% of the data all the way up here, which would give us 1.248 plus 0.004. If you're not doing it in your head, do it in your calculator. You should get 1.252. All right, you try this one by yourself and then run it past me in class. By all means, check with your seatmates. If you don't all agree, ask me what's going on. If you do all agree, most likely you're right. So make sure you pause this so that you can get that done before we go to the next part. All right, so now for your actual assignment, you get a chance to apply this. We get a chance to make this useful in real life problems. So Aaliyah scored a 95 on her last test. So that's a little bit of information. 95 on her last test. And that was exactly 3 standard deviations above the mean. The standard deviation was 4. They're telling us that. And we want to find out what was the mean grade. So that's the question. So what's going to help the most to do this is draw yourself a little normal curve, okay? And we're trying to find out what is the mean. We want to know what's the middle. What we do know is that her score was 3 above the mean. Now make sure when you read these, you're paying attention to whether it's above or below, because you'll either be going to the right or to the left. If it's above the mean, we're going to add, and this time it said 3 standard deviations. So 1, 2, 3 standard deviations. And the standard deviation was 4, 4, 4, 4. And her score was a 95. So in order to find out what the mean was, we'll have to go backward 4. When you added 4 and 4 and 4, you got to 95. So we'll take 95 and we'll minus 4, minus 4, minus 4. Or in other words, minus 12. So what is that mean going to be? Hopefully you said 83. 83 would be the mean. And you can double check it. If 83 is the mean and you go, the standard deviation was 4, and you do it 3 times, 83 plus 4 is 87, plus 4 is 91, plus 4 is 95, which was her score, which was 3 standard deviations above the mean. So the mean was 83. Mean equals 83. So that's your job. Now pay attention carefully about whether it's above or below the mean, so you make sure you put it on the right side of the mean. Sometimes it might be over here this direction. Okay, do your best. Check the answer key on JT Learn when you're finished so that you can be sure you're getting it right, and ask me any questions. Good luck, you can do it.